Welcome at the high-tech factory in Enschede. My name is Aleksandar Andreski. I work at the Saxion Department of Nanotechnology. I will be your guide today through our facilities. Come in. Hi. During the development of new technological products, for instance a new drug, a new sensor, or an exciting new 3D print material, there is a development stage called the characterization stage. It is called differently in the different domains in chemistry, biology, physics, but the goal remains the same. Describe and understand the behavior of your new product in realistic circumstances. For example, your new drug may have side effects. Maybe the sensor works excellently alone, but when integrated with other sensors in a system, they interfere. Or during the production synthesis of your new 3D print material, there is one step which is very stubborn and does not let itself be scaled up to industrial level. While in the previous development stages, you're working out your scientific discovery or trying to prove the principle of your new idea. Here, you're trying to see whether your new product is practically useful. Unfortunately, many new discoveries get stuck on this stage. Many companies, startup companies, do not succeed because they found out that their products, although very good ideas, they were not practical enough. We stand in a characterization lab for two types of sensors, for two types of devices, I should say. On that side, we have microfluidic devices, and on this side, we are working with gas sensors. If you want to know more about this, follow me. During the characterization of sensor devices, use is made of the so-called stimulus-response method. There, we apply a well-known and controlled input while observing the response or the output of our device. Iterating the input conditions, we can then slowly build a picture of how our device behaves under different circumstances. Analyzing this input-output data and making quantitative models out of it, we can adjust our expectations or make new predictions. A fun fact is that we can also make new discoveries. Often, these are more useful than the original intention of our product. Many startup companies, if you look at the histories, began with idea A, but ended up with idea B, C, or D derived from idea A. So although scientifically, academically, characterization and all that measurement is not very attractive, it is a lot of fun for innovation-minded engineers, what we do at the Saxion. So, if you want to know more about microfluidic stimulus experiments, follow me. Microfluidics are miniaturized chemical labs on a small glass chip. Liquid flows through microchannels and interact with each other in a useful way. So, for instance, you can make a blot analysis or build a microreactor. Microfluidic devices are characterized by using very low sample volumes. Therefore, also, the stimulus system that we have to use during the characterization needs to be able to deliver very low flows in an accurate way. Secondly, we also need to be able to switch the liquid type so as to provide the appropriate stimulus for our device. There are two components in a microfluidic liquid delivery system. First is the flow component, which takes care that the basic liquid or the carrier is delivered with a very accurate and well-controlled flow, and the injection subsystem, which takes care of the switching between the two liquids. If you want to know more about these two components, make your choice now. Let's talk about the flow control part of the microfluidic delivery system. We start with a liquid pressurized vessel, or better known as a beer keg, and it is a real beer keg. As you all know, liquids in a beer keg are kept under pressure, and with the handle of the valve, you can control how much beer you can get out of your beer keg. Here we have a very similar principle. The liquid is contained in this beer keg, pressurized by external pressure line, and instead of that handle, we have a more sophisticated system. We have a valve, which is controlled by a flow meter. The flow meter measures the flow and gives a signal back to the valve how much to open or close. In that way, you create a very stable and very accurate flow through your microfluidic device. Let's talk about the injection part of the microfluidic liquid delivery system. The purpose of this part is to switch the liquid type as it flows towards our device under test. That way you can generate a stimulus with different liquids of your microfluidic device and, as we all know, characterize it by looking at the output that it generates. How it is done? The device which is responsible for doing that is the injection valve. In effect, this injection valve takes part of the line between our beer vat and the device and replaces it with a pre-filled line or some other liquids. That way, you generate what we call a plug flow from a different liquid inside the carrier liquid. As the carrier liquid is dispensed, so also does this plug flow towards our microfluidic device, generating the necessary stimulus.